Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2462 that says total cost to hire key workers. So guys, this question is a very good question as it will help you to revise multiple data structures like two pointers and as well as priority queue. Also in this video we will start off with a brute force approach, and then we will try to optimize different steps of the brute force approach and then move on to the most optimal solution. So yeah, this way we will derive the optimal solution starting with the brute force approach. So yeah guys, stick till the end and watch the complete video. Now moving on to the question understanding part. So here, as the title suggests, that you are asked to hire key workers and you need to minimize the total cost to hire key workers. So our goal is to minimize the total cost. So in the input array you will be given one cost that will state the cost of the ith worker, as well as one integer k that determines that how many workers we need to select. Now apart from these two, cost and key, you will be also given one integer candidates. So the question states that if you want to select one candidate, what you have to do is, or you can say if you want to select one worker, then you can take let's assume candidate as x. So you can take x workers from front into the bucket, x workers from back into the bucket. So for this you can take 3, 2. So let's assume this as a bucket. So bucket will have 3, 2, 1 and 2. 4 workers inside the bucket. Now from this bucket you can select the worker with the minimum cost. Okay. So that means that you cannot randomly select any worker with a minimum cost. You have to take x workers from the front, x worker from the back, and from these workers only you can select the worker with a minimum cost. You cannot select any worker with a minimum cost. Okay, got it? So at the end we need to reduce the total cost, and so for that it is intuited that we will select the worker with a minimum cost, but we cannot select any of the workers. We have to select only x number of workers from the front, x number of workers from this back, and from these two sets we have to select the worker with the total minimum, with the minimum cost. Okay, so understood this, that we are selecting x or the candidate number of workers from the front and from the back, and we place for an assume that we place in the bucket. So now from this bucket only we can select the one with the minimum cost. Okay, now and if there are fewer candidates worker remaining, then choose the lowest cost among them. Okay, and yeah, if you want to break a tie, let's say there are so here if you see, let's say there is some test case like this 3, 2, 4, 2. Now you have to select 2 workers from the front, 2 from the back. Now if you see, this is the minimum and this is the minimum from the back. So there is a tie. Okay, because the this from this set, from the front set, the minimum worker has a cost 2, and from the back set also the minimum cost of the worker is 2. Now which worker to select? Then you will select the worker with the smallest index. So in case of tie, choose the smallest index worker. Okay, got it? So if you are still any confusion, then yeah, we will look at the first example or the first test case for better understanding. So now here, this is the cost array, this is the k, and these are the candidates. Now let's say if you want to choose the first worker, so for that what you will do is you can take 4 workers from the front. So these are these 4 workers, 4 workers from the back, from this. So you have 2 set, right? This is the front set and this is the back set. Now from this 2 set you can select the one with a minimum cost. So here it is 2 from the front side, it is 2, and from the back side it is also 2. Now there is a tie. So in a tie we will choose the worker with the smallest index. Okay, and that would be nothing but a worker present in the front side. Okay, so here we choose the one with the smallest index, which is index 3. So this worker, so our total cost currently is 2. Now for the next iteration, for k equals to 2, that means we have to choose the second worker. Okay, so now these 2 we have removed because we have already selected. So we have 2 sets right now, these 2 sets. This is the first set and this is the second set. Now here the lowest element or the worker with the lowest cost is this 2, and in the left it is 7 is the lowest. Okay, so yeah, 2 is there and there is no tie here, so we will select this worker with a cost 2. So total cost is 4. Okay, till now. Now in the third round, our left set would be this and right set would be this. See, we haven't changed the right set because it's ending, right? So here initially we haven't made right set to start from here. That is because there is this element 7 is already a part of left set. So yeah, we cannot increase the number of elements in the right set. So now we will choose what is the minimum. So minimum from the left set is 7 and from the right set is 8. So a minimum of both of them is 7. So we added 7 to our answer, and total cost till now is 11. Okay. So after this, for the k equal to 4, we don't want to hire 4 workers, right? Because the k at max can be 3. So we perform this activity 3 times, and the total cost after this 3 iteration is 11. So we return 11 as our answer. Okay. Now here we have k equals to 3 and candidates equal to 3. Okay. So for so assume that this is our front set and this is our back set, front and back, because candidate size is 3. So we selected this as a front set of a size 3. Now for the back set, it can be only of a size 1. Okay. Now for the first iteration, you can see this one is minimum and this one is also minimum. Okay. Let me draw it clearly. This is the back set. So this one is minimum and this one is minimum. There is a tie. So whenever it is a tie, we choose the worker with the slowest index. So that is this worker. Now for the next iteration, here 2 is minimum and here 1 is minimum. So minimum of both the set is again 1. So yeah, we select this one. And for the third round, because k equals to 3, here we have 2 and we don't have anything on the right. So yeah, we selected these 2. Okay, we selected these 2 and yeah, we added to our answer. So 2 plus 1 plus 1. So overall cost is 4. So yeah, that's why we written 4 to our answer. So I hope you guys have understood the question. I feel that yeah, this question is a bit tough to explain for me, but if you try to make a dry run of this given test cases, then you will understand it easily. Okay, clear till you? So what brute force approach you can think of by understanding this question? Say the brute force approach you can think of is, what we are trying to do is at every step what we are doing is selecting candidates number of worker from the front and selecting candidates number of worker from the back. Okay, so what we can do is we can store this candidate number of worker from the front into this vector v1 that are not visited. Okay, I will explain you this thing in a few minutes. And then what we are doing is we are selecting candidate number of workers from the back, and let's say we store it in a v2. Now the next step is we have to choose the worker with a minimum cost from both v1 and v2. So what we can do is we can either sort v1 and v2 and compare the minimum element. This is one way to solve this question. Okay, and if there is a tie, then we can take element from v1 because the elements of the v1 are have the minimum index. So that is a way we can do is we can sort both v1 and v2 and then choose an element that is minimum of both. Okay, and if there is a tie, then we will select the element from v1 only. Now the next step is the element that we have selected, we have to mark it as visited so that we don't consider it in the next iteration. So what we will do is we will mark that as visited. Okay, so this is one iteration, right? This is one iteration. Now in the next iteration, we would choose candidate number of workers from the front and that are not visited, and similarly we would choose candidate number of workers from the back that are not visited. Again sort them, again find the minimum of both the sets and take the minimum into our answer and then mark the element that you took as visited. So yeah, this is the iteration that we have to keep on doing, right, until k equals to 0, means until we have hired k number of workers. Okay, so I hope you guys can easily code for this brute force approach because it is very much simple, that we are simply selecting the elements and storing in the vector, sorting them, finding the minimum element and marking it visited, and similarly processing or doing this thing for all k times. Okay, now if you think of a time complexity for this brute force approach, it would be let's say the x is the number of candidates. So for this thing we need to store x number of workers, right, in the v1 and v2. So that will take x times, because x times of iteration we have to do to store in vector 1 and vector 2. Then what we are doing, we are sorting them, so that is nothing but x log of x, right, and we are performing these k times. Okay, we are performing this k times because we have to select k workers. So for each worker to select, we are performing this activity. Also, let's say x is the number of candidates, but we are performing this activity by taking x number of elements from the front as well as x number of elements from the back. So it is k multiplied by 2, right? Because we are performing this activity from the front as well as from the back. So yeah, we multiplied by 2. So this would be the time complexity for this brute force approach, and it will surely give you time limit exceeded, because the constraints are up to 10 to the power 5. Okay, cost candidates can be up to 10 to the power 5. So that's why this will give you time limit exceeded error. Now we need to use this brute force approach in order to move towards, or in order to find the most optimal answer. So what optimization we can do in this brute force approach? So optimizing the brute force approach, first thing what we are doing is we were sorting the element to find the minimum of set 1 and set 2. Okay, see guys, in a sorting what we do is we sort all the elements, right? All the elements are sorted. That means all the elements are placed at a correct index, but we only need to find minimum of set 1 and set 2. We only need to find the minimum. We don't care of other elements, if our other elements placed at the correct index or not. We don't care. We only need to find what is the minimum index. And how we can do that? We can simply do that by using priority queue or min-heap. Okay, so yeah, min-heap will help us to get the minimum elements from the set 1 as well as set 2. Okay, so instead of sorting, what we can do is we can use min-heap, as we only need the minimum element from both the sets. Okay, so keep this in mind. Okay, now the next thing is, what we were doing is we were creating vectors v1 and v2 for each kth iteration. Okay, so instead of that, what we can do is we will store k means candidate number of elements from the front into min-heap, candidate number of elements from the back into min-heap, and then each time when we pop some element, let's say in a one iteration we are popping some element from, we would pop some element from the min-heap, that is minimum, and at the same time we would add only one new element, right? Because what we have to do is we have to only take candidates number of elements from the front, from the back, and each time what modification we do is we will either pick one of the element from either of the set and remove it. Okay, and we were marking that as visited. Okay, so there would be some elements remaining in both this. So instead of creating both these sets again, what we would do is we would add one more element. So let's say this was the initial set, then, and we have removed one element from this set from the left side, then we would add one element to it, right? That is not visited. So yeah, instead of creating vectors each time for each iteration, we would use min-heap, initialize min-heap once, and then we would keep adding the element whenever we pop some new element. Okay, now this might be a bit hard to understand, but let's make a dry run so that you can get a clear idea of what we are trying to do here. So in a dry run, I have taken this cost vector. So this is the cost vector, the k is 3, and this is the candidates. That means you can select two candidates from the front and 2 from the back, and then choose a minimum of both of them. And you have to perform this iteration 3 times, because k is 3 here. Now for the first iteration, see, you can choose 2 elements from the front, 2 from the back. Then what we would do is we would insert this element to the min-heap. Okay, so min-heap will contain 6, 9, 4 and 8, these 4 elements, and then we would choose the minimum of them. So that minimum element would be present at the top of the min-heap, because this is the min-heap, and the topmost element would be minimum of all the element. So this minimum element would be 4. We would add it to our answer, and after that what we would do is we would add one new element. Now one new element that we are adding, that would be nothing but either right side of the left side or left side or the right side. Okay, let me clear this. So here we have taken these 4. So now this 4 was a part of the right side. Okay, it was part of this right side. Now we need to add one new element. So that new element would be nothing but these 6. So that is left of the right side, because we have chosen an element from the right side, so we have to update the right side. So that means we would choose one more element that is left of the right side. Okay, see here it is ending, but this right side left boundary we can increase. So yeah, for this right side we have increased the left boundary and included this element. Okay, so why we did this? See, that is because, so let's say you have 6, 9, 2, 6, 4, 8, 6, 9, 2, 6, 4, 8. You chose 6, 9 and 4, 8. This was initially, you remove this. So for the next iteration, what what you would do in the brute force approach, you will select candidate number of element from the front and candidate number of element from the back. Okay, so in that case, the new candidate that would be added to the right side would be 6, right, and not this 2 and not any other element. See, this left set would remain the same, but the right set would change because we have used one element from the right side. Now the new element that would be added to the right side would be the left of this right side, right, so that this would be added into the right side. So yeah, we will choose an element that is left of the right side and add it to the minimum heap. So one element is added from back. So now for k equals to 2, so that is second iteration. So now this is the min heap 6 9 6 8, right. So from this, the minimum element is this 6 and not this 6. This 6 with the index 0, that means this one 0 1 2 3 4 5. So this is the minimum element. So there is, although there is a type, but we will choose the one which has the least index, and that is this. So we would choose this, we would remove this, and now since we have removed the element from the left side, we would take an element that is right side of the left side. So we would take this element. So we have inserted 2 to min heap. So now the min heap is like 2 9 6 8. Okay, there is one element from the front added from the front or the front side. Now for k equals to 3, this is the currently this is the minimum heap, right. Now minimum of this element is 2, so we would remove 2, add to our answer. So the remaining minimum heap would be 968. Now we don't add anything here because all the elements of this cost are already present and already processed, right. There is no element remaining, because if you see that we have taken this 2, so ideally we would select right element of this left side, but the rightmost element of this left side is already a part of right side. So that means we cannot include 6 2 times, we cannot do that. So that's why here we are not adding anything. So guys, based on this, what you can understand is we have to use 2 pointers. One pointer to point what is the ending of the left side and what is the starting of the right side, right, because the left side would increase towards the right and right side would increase towards the left. So we have to keep 2 pointers. One pointer will point towards the ending of the left side, other pointer will point towards the starting of the right side. So yeah, that's how 2 pointer approach is derived. You can intuitively think 2 pointers approach this way by doing a dry run, because we need to keep track of index of left side, and you need to keep track of start index of right side, right. So we will use 2 pointers, I pointer and j pointer, to keep track of these 2 things. Okay, now guys, you understood this, that why we would use 2 pointers, why we would use priority queue, that is a min heap. And yeah, now combining all this, let's move on to the code. So coding in the code here, what we did is we took a priority queue of a pair, not of int but a pair, because we will also store the index of the element along with the value. So to store the index, we took a pair and created this min heap, and then we pushed the first k elements or first candidate number of workers into the min heap, and the last candidate number of workers into the min heap. Now see, you might be wondering that why I did I minus minus and j plus plus, because for the last iteration where we did I plus plus and this condition is failed, at that time I would be pointing to one more element, so we don't want that. So yeah, to keep the boundary intact, we did I minus minus and j plus plus, because for the last iteration of this while loop, j would be j minus decremented one more time, but we don't want that as per this condition. So yeah, that's why we did this I minus minus and j plus plus. And then for k times, what we are doing is we will take the minimum element, so that would be present on the top, add pop that minimum element and add to the answer. Now we would see if I plus 1 is less than j, that is the rightmost element of the left side, is it a part of a right side or not. If it is not a part, then what we would do is we can add that new element to our minimum and do I plus plus. And similarly, if we would check if j minus 1, if it is that element j minus 1 is a part of left side or not. If it is not a part, then yeah, we can add that j minus 1 element. So we are doing j minus minus, and the new jth element we are adding. See, also yeah, we since we have stored the index of the element that we have popped, so based on the index, if the index is less than the right boundary of the left side, then it is a part of the left side, and if index greater than left boundary of the right side, then it is a part of the right side. Okay, so that's why in order to know that the element we have removed is a part of which side, we are storing the index, and yeah, at the end we return the answer. Okay, so I hope you guys have now understood that what we are trying to do here and how we have come up with this approach to solve this question, right? We have intuitively derived the approach from the brute force to the most optimal one. Now talking about the time complexity, so min-heap insertion will take big O of log of n time, as well as pop will take big O of log of n time. This is because that whenever we insert a new element or remove the element from the minimum heap, it will heapify itself, right? So that's why it takes heapified step takes big O of log of n time. Now here let's consider x as a minimum of n or twice of the candidates. Okay, so the at max the size of min heap would be 2x. That means because we are storing only candidate number of elements of the set 1 and set 2 to our minimum heap. Minimum heap contains both candidate number of elements of the left side as well as candidate number of elements at the right side, and at each time when we pop, at that time only we are adding, so the maximum size of the min heap would be twice of x. Okay, so insertion will take 2x log of 2x. Okay, because for 2x times we are inserting, so that would be 2x log of 2x, and for one time of insert it will take this, so for 2x time we have to multiply. And how many times we are performing this pop operation? We are performing pop operation k log of 2x time. Okay, see, log of 2x is nothing but the size of the min heap, and if you perform this pop operation, then it will take this time complexity, that is the size of the min heap. We are performing it k times, so the pop operation will take this many moves, right? So yeah, the overall time complexity would be 2x plus k multiplied by log of 2x. See, log of 2x, this thing is common in both, so we took this in common and we added this 2x plus k. Okay, got it? Clear till here? And space complexity is nothing but the size of the minimum heap, and that is nothing but 2x, right? That is a set, that is a number of elements of the set 1 as well as set 2. So yeah guys, that's all for this video. If you guys have any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.